And we'll go from current slide. And before we get started there, let me make a few announcements. Now, some of these are ones you probably have heard before, and then there's a couple new ones that I'll be telling you too. First, if you're interested in participating with the math team, it's a great way to have a lot of fun with math, learn stuff that you'll be using in courses from now on, okay? See Miss Nyla Gerasi. She's on the Birmingham campus. They meet Friday at noon in room C100. That's on the Birmingham West campus, the science building, which is the C Hall, and it's in room 100. Then they meet again Monday afternoon at 3 o'clock, same place, okay? And if any of you want to meet here, we can go over questions here too. Just have to find the time in my schedule, and we'll be talking about that in just a minute. There are lots of tutoring opportunities. I think I've told you one is down the hall here is Student Support Services. They have professional tutors and peer tutors. Can almost schedule at any time of the day. Just get with them and work that out. And downstairs in the Space Center, there's a little bit more limited hours, but I think I've actually heard that some of these hours have been extended and days have been extended. So that's on this campus, and then there's more opportunities on the Birmingham campus as well. And too late for that one, it's over with. All right, here is a new announcement from the home front, okay? Yesterday was the first day of the first mini-term, of the second mini-term. And this is Courtney, right? Courtney, right? Courtney, right? Okay, there you are. All right. Now, that leads to a couple of issues. Number one, I was hoping to have the second test already by now, but we did lose at least one day and maybe 2 days early in the term because of weather and scheduling and things like that. So I think we're still okay on track. We might need to pick up the pace just a little bit to make sure we finish everything by the end of the term. But that's, we'll deal with that. But the other thing, the second mini term, well, here's yet another one. And this is, remind me, Somalia. Okay. There you are. All right. No, it was Kayla that called today. You didn't call and talk to me on the phone. Okay. I thought it was Kayla. Okay. All right. The other issue with being midterm is that typically they open and request us to submit midterm progress reports. Now, I've already started doing that for this class because I started it after the first, either after the first quiz or test, you know, somewhere in that time frame. But they'll probably ask for another, and I'll do another. Now, I'm preaching to the choir here almost because y'all are here just about every day, and you've been keeping up, and you're on track. Everything's going hunky-dory, okay? It's the people who aren't here that are not, haven't turned in any work or very little work, and I don't know how you're doing in the course because they're not here to evaluate. So mostly it'll be them that'll be getting things. They only ask for D's and F's at midterm, and I'll be submitting that when they request it. That was number two about being midterm. The third issue is I picked up 2 more courses at mini-term, okay? I've got 2 second mini-term courses. I didn't have first mini-term, so it isn't like I lost 2 and picked up 2. I still have the 4 I had before plus 2 more, okay? So that changes my office hours pretty significantly. So here's the new office hours. I'm going to try to get this, put a new locator card out there on Blackboard and change the syllabus to reflect the second mini-term office hours. Haven't done it yet. Don't know when I'm going to get a chance to, but I'll try to get it done as soon as I can. All right, here's my new office hours. On Mondays and Wednesdays when we meet, Evelyn's here. Okay, Monday, Wednesdays when we meet. Still have office hours from 7:45 till 9:30, so that hasn't changed. Still have office hours from 10:15 until this class, 11:15 until the class starts at 2. That hasn't changed. But before, on Monday, for instance, I had office hours from 3:15 when the class is over until 5:15. No longer, okay, because I picked up a 4 to 6 class on the Birmingham East Campus. That means as soon as we finish here, this class, 3:15, I've got to get all my stuff together and get on the road by 3:30 so I can be there by 4 o'clock. Okay, I allow myself half an hour. Most of the time I can make it in less than that. But if there's a train, I'm going to be late. So I did want to let you know my office hours after class are going to be very limited, no more than 15 minutes. And much of that time I'm going to be occupied trying to get ready and all the stuff loaded. Because you see, it's not only the stuff I need over there for that class, it's everything I'm going to take home with me. I have to make sure I've got all that done because I don't come back here, I just go straight home after 6. All right, Tuesdays and Thursdays. My office hours were 10:45 until 5:15. No longer. Now they go to 10:45 to 1:15 because at 1:15 I pick up a second mini-term physical science class, and because it's got a lab with it, it's a 3-hour class, 2-hour lab, so every day is 4.5 hours, okay? Every day, every Tuesday and Thursday. So from 1:15 to 3:45 we're in class, though sometimes it might be lab, and then from 3:45 to 5:45 is technically the lab time. So I'm booked solid after 1:15 until 5:45. Now I'm usually here another 15 minutes or so, just shutting down the lab or cleaning up, whatever, and getting my stuff ready to go home. So you can maybe, you'll usually be able to catch me 5:45 to 6, but I doubt if many of you are around then. All right, so those are the new office hours. Fridays are still the same, except for this Friday. I've got a treatment this Friday, so I will not be on either campus this Friday because that's happening. Now, I believe it was Michaela that called, and we were talking on the phone. I didn't have my book in front of me. I said, we finished the last chapter. She was asking about the quiz, getting that in. The quiz, getting that in. The quiz, getting that. Okay, good. Just want to remind people that due any time now. But you'll have to have it in today, but please, I hope you're working on it. And then she said, when's the test? I said, well, if I get enough quizzes in today, the test will be Monday. That's still going to be the case. If I don't, then we'll probably have to continue in chapter 13 and have the quiz on Wednesday, the test on Wednesday. But we'll see. We'll determine that by the end of the term, end of the class. But then she said, and what do we do next? I said, well, actually, we finished chapter 11 last time, so we'll move on to the next chapter. And I was thinking it was 12, linear systems of equations. I forgot, no, it's not. It's chapter 13, exponents and polynomials. So I'm saying this, hoping Michaela is listening. I told you the wrong chapter. We're doing 13 today, starting 13 today. Now, for y'all, any questions? Okay. Hope you're making good progress on the quiz. If you do have any questions on the quiz, clarification, yes, I can do that, no problem. But if it's, how do you do number 7? Now, I'm not going to answer that. That's why it's a quiz. You're supposed to find anything in the book similar to it. I'll work anything from the book as long as it's not identically the same problem. So that's always the case, so please bring it. So I take it that there's no more questions? All right. Then we are in chapter 13, exponents and radicals. Okay? Pretty interesting little thing on the front, the national debt. Our national debt. And it is now in hundreds, thousands, millions, billions, 15.6 or 7 trillion dollars. And growing, this new tax cut for the rich, really, I'm sorry, I didn't say that, did I? Okay, that is increasing the debt majorly, okay, with a conservative Congress and White House. That's really interesting. All right, never mind. That's politics. So, frankly, that's a long thing to say all that on the debt, whereas we could say 15 times 10 to the 12, and that would be an easier way to say it, or 15.68 times 10 to the 12. Okay. So, 13.1. We're going to start with adding, subtracting, and subtracting polynomials. Okay? We'll probably talk a little bit, yeah, it says that, about what a polynomial is. We'll do a little bit of that too. We'll review combining like terms. Hopefully you've had that before, and it will be a review. We'll know the vocabulary for polynomials. I think you're probably already familiar with that. We'll evaluate polynomials, a very nice thing to do. We'll add and subtract polynomials, and then we'll add and subtract polynomials with more than one variable. Okay? So those are the objectives for this section. Let's start with example 1. This is supposed to be a review, so let's review. Now, herein is where I think we can speed up just a little bit. I would say let's either do the example that's in the slide set or the example that's in the text. I don't think we're going to have time for both of them because there's more sections in this chapter than there were in the previous 2 chapters. So which you want to do? The ones in the text, ones on the on the slide here. You tell me. Actually, the one in the text has 3 parts. This one only has, well, no, it may have more than one. Okay. Yeah, it has 3. Okay, we'll do the one here. Okay. Here it says, simplify each expression by adding like terms. Okay? What do we mean by a like term? Wait. Time out. What do we mean by a term? Anyone know what you mean by a term? Okay. In an expression, you have some things that are multiplied, like -3 times x to the 5th. That's a multiplication. You don't see a times sign, you just know when a number is written next to a letter, that means multiply, if you don't have a sign in between. And even the x to the 5th, what does that mean? X times x times x times x times x. That's multiplication. Okay? But anytime in an expression that you have a plus or a minus sign, that separates terms. These are factors within a term. Greg draws here, a factor within a term. No, okay. I can't write on that with that pen. Okay, here he is. Okay, so what a term is anything in a, and we haven't even defined what a polynomial is yet, in a polynomial expression that's separated by a plus or minus sign. So what are our 2 terms, or how many terms do you see there? 2. What are they? Say again? Okay, no, those are the coefficients. The terms are -3x to the 5th, 7x to the 5th. Those are our 2 terms. Now, what do we mean by like terms? The what?
They're similar. They match.
Okay, similar, match. What do you mean by that? Are they the same?
They're the same variables.
Ah! That's one issue. Same, identically the same variables. But there's another issue. At identically the same powers. This could have been -3x 5th plus 7x to the 4th. Same variable. But unless they're at the same power, they're not like terms, not similar terms. So they have to be the same variables with the same powers, identically the same. The coefficients don't matter at all. The -3 and the 7 are coefficients. They can be anything. Okay? Very good. Okay, so combine or adding like terms here, what do we get? Whoa, let me get my pen. Okay. Yeah, that's going to be a 4x to the 5th. Okay? You only add and subtract the coefficients. Yeah. Okay, got it. Thank you so much. I appreciate it. I'm going to bring that book back to you as soon as I have a second. library staff is usually most of the time. Okay, so does that make sense? Now, how or why could we do it that way? If you think about it, these two terms have that x to the fifth in common, right? Same variable, same expression. So you can factor those out, and you're left with negative 3 plus 7 times x to the fifth. You know, distribute it. And negative 3 plus 7 is 4, positive 4 times x to the fifth. That's exactly what we do with combining like terms. Any question? You see it? Okay, let's see how they did it. They did it exactly that way. They factored out the x to the fifth. That's why it has to be identically the same variable and identically the same power. Otherwise, you couldn't factor it out. And you're distributing the other way, and you're left with negative 3 plus 7 in front. And then you can do that addition of those numbers, you assign numbers. That would be 4x to the fifth. Fantastic. You see it? That's all we mean by combining like terms. Okay? How about this one? What would that be? 6 into the third. Perfect. Perfect. Because you have the like terms, because n is in every term, and it's exactly the third power in every term. So factor that out, and you have 2 plus 5, 7, minus 1. If you don't see a coefficient, you understand it to be 1. If you don't see an exponent, you understand it to be 1. Okay? And we'll get to something else, I think, later in the chapter, maybe another chapter. Sometimes it's not always a 1 if you don't see it. That's with radicals. If you have a square root symbol, the index, if you don't see it, is a 2, not a 1. That's the only place that doesn't work. Okay? So, yes?
So did we take the 7 from the 1 that you know, the
coefficients. Yeah.
That's supposed to be a 1. So we actually subtracted from that?
Yes.
That's how we
Okay.
got the 16.
2 plus 5 is 7, and you understand if you don't see there's a 1 there, subtract 1 from 7, that gives you 6.
Thank you.
Yeah, good deal. Good question. Okay? And here they do it, factoring out or distributing out the n cubed. That's why it has to be identically the same in every term, and your coefficients are 2 plus 5 minus 1, because if you don't see a number there, you understand it to be a 1. 2 plus 5 is 7, minus 1 is 6, 6 and 3. 6 into the third. Okay? Any questions? Good deal. How about C? Yeah. Okay, sorry. I get quick on the fingers sometimes. Very seldom. I'm usually the slowest person on the block. So. Okay, good deal. Okay, how about this one? -3 is what I heard. Okay, you don't need the parentheses there. I was starting to put it, but y'all are doing it without the parentheses, so I'll do it. Okay. G to the 7th, H to the 4th. Perfect. Way to go. Because you have a G in every term, and they're all at the 7th power, and H in every term, they're all at the 4th power, so you can distribute that out, factor it out, separate it from the other, leaving your coefficients of 4 minus 9 plus 2. You can do that any way you want to. I sort of like to do the positives first. 4 plus 2 is 6, minus 9 would be a -3. Or you can go as you read it. 4 minus 9 is -5, plus 2 is -3. It works either way. Any questions? All right, good deal. Is it making sense? Okay. Remember, the variables have to be identical at identical powers. All right, that's what they did. They got the same answer. Good for them. See if they have a D. No, they don't have a D. All right. I was wrong. The one in the book also has a D, E, and an F. So you want to do those? Because we only did 3, they have 6. For some reason I glanced down and only saw 3. There are 6 of them there. So let's do, we won't do the first 3. They're not the same, but let's do D from the text. Okay? Y plus 2/3 Y. What in the world would you do with that? Okay, that is certainly a legitimate way, if I could write, to write it. Okay? 1 and 2/3 Y would be perfectly fine. Okay, I'm happy with that. I'm perfectly fine with that. However, if you're doing my math lab, I bet you they have one and only one acceptable way to write it, and I bet you it's not that. Okay? Now, so if you're trying to keep up with my math lab, which I think you got the codes and stuff for, and you see something like that, and you put that down and they say it's wrong, before you guess, no, I did something wrong, try this. How do you write this as an improper fraction? Yes, it's 3 times 1 is 3 plus 2 is 5. That would be 5/3 Y. And that's what they have in the book. It's no better, no worse, same type of deal. Okay? Now, let me say this. If they had given you, say, Y plus 7/3 Y, then they put this in improper fraction, I would expect the answer to be an improper fraction. But here, where one of them's just got a number, one of them's got a fraction, they're both that's a proper fraction, that looks like a perfectly good answer. Now, another way you can do this, and I'll do this a lot because to me it's easy to see. What's the coefficient here? 1. How many thirds is 1? Second? 3/3, exactly, right? If you had one, I think in terms of food, if you had a pie and you split it into thirds, how many thirds of a pie do you have? 3, of course. So you could then also do it this way. Write this as 3/3 pi, Y, back on the food again, plus 2/3 pi. I said it again. Y, okay? When I get food on the mind, it's hard to get rid of it. And then how do we add those? Keep the denominator, add the numerator. If it's a common denominator, keep the denominator, add the numerators, and that gives you 5/3. Why? I said it right that time. Okay? And that's the answer they got in the book. Okay? Let's see if we can squeeze in E here. Okay? E here is 12m squared plus 5m plus 4m squared. What would that be? A little louder. 16m squared plus 5m. Even though it's the same variable, it's not at identically the same powers. You can only combine the like terms, not the one that is different. So this becomes 16m squared. Just bring down 5. Can't throw it away. You can't ignore it. Just bring it down. Okay? That's your answer. And that's what they got in the book. Does that make sense? Good deal.
Wait a minute.
Okay. All right. Yeah. I'd like you to send that home to my wife. She doesn't think I'm quick with anything. So, yeah, never mind. Okay. All right. F. For Fowler. No, okay. 5u plus 11v. Combine like terms. Say again? That's the v. 5u plus 11v. Okay, there aren't any like terms. That is a simplified form. Simplify each expression. You cannot simplify that any further. Not undefined, that is as simple as it will get. There aren't any like terms. Don't even try. Even if that had been 5u plus 5v, there's nothing you can do with it because they're not like terms. You can only combine or add like terms. Yes?
Now, do we contest is undefined or we just put correct?
You just leave it right like that. The only thing that's undefined is trying to divide by 0. Okay? So, since that has no division by 0, write it, just leave it like that. That is simplified form. Okay. Now, A, B, and C in the book are still there you can work on, and you have in the margin some you can do. So there's plenty there that you can look at.
What page?
That's on page 850. Okay? Now, all right, we already did that. This is, yeah, I got it. Just finding you is the next part. Yeah, all right. Good deal. We're in chapter 13, 13.1. We're just at the top of page 851. All right, 851 is knowing, the objective 2 is knowing the vocabulary for polynomials. Now, I've already been saying it to some extent. We talked about what terms were and things like this. Here's some other vocabulary, okay? When you simplify a polynomial, for instance, this one, can that be simplified? No, that's as simple as you can get. So at the end, when you simplified it, you can tell me several things about that polynomial. One thing, there's a term that tells you, a wording that tells you how many terms are here. How many? 2. So we have a special name for that polynomial, a binomial. It's sort of like bi for 2, bicycle, 2 wheels, you know. Bi, polynomial, nomial. 2 terms, that's what that means. Okay? Now, the other thing that you do is look at the maximum exponent. That tells you the degree of the polynomial. How hot it not that is. The degree of the polynomial. And this one would be fourth degree polynomial. Because this, what's the degree of this one, by the way?
1.
That, no, not 1. That would have to have a t in it to be a 1. It would be a 0th degree polynomial, term, because it's t to the 0. What's t to the 0? T to the 0. Anything to the 0th power is? Who knows? 1. Anything, except 0 to the 0th is not defined. But anything else. T to the 0th, 4,584,815.3 to the 0th power is 1. Okay? No matter what you got, if it's the 0th power, and that's what you got here. T to the 0th power is 1, so you don't write it down. 7 times 1 is 7. Okay. So, that is a binomial 4th degree polynomial. Okay? Good deal. Now, usually the names that we have, if it's only 1 term, once you've simplified it, it's a monomial. If it's 2 terms, it's a binomial. 3 terms, a trinomial. Okay? Anything beyond that, we just say a 4 term, a 7 term, or whatever. They say none of these. Well, call it a 7 term polynomial, you know. But it's going to be, we only name those first 3. And then the degree, whatever degree it is. That just follows it. Okay. So simplify, it is simplified. And you've already told me it's a binomial and, of degree 4. We talked through that one. Okay? So let's see what they say. The polynomial cannot be simplified. The degree is 4. Oh, look at that fancy little balloon. And it's moving on me. Okay? The polynomial is a binomial because it has 2 terms. Okay? I didn't do that. The program did it. I wasn't going too fast. Okay. Everybody got it? All right. All right, there's one other issue. Let me just talk about while y'all are writing that down. Generally, our standard form for a polynomial is going to be descending orders of the power. Most of the time we would not write that as 7 plus 2t fourth. It's fine, it's correct, it's a fourth degree polynomial, a binomial, everything's the same, but in standard form we usually put it descending order of the powers, not ascending order. So you do the t to the fourth or you do t to the 0. Even though you don't see t to the 0. So they didn't mention that in the problem here, but it is in correct order. All right, to go on to B. All right. I really don't like this one, but it's okay. It says simplify the polynomial if possible. So, if possible, is it? What is it? Negative e to the second power. Okay? So you've simplified it. Now tell me what type of polynomial is and what degree it is. A monomial, second degree monomial. Exactly. Okay? Now, I don't like them using e as a variable. And here's why. In upper level math that you'll get to one of these days, e is a very special number. It's the natural base of our number system. We say we use a base 10 number system. That's just because we have 10 fingers, you know. That's in counting, that's what we do. But once you get into going toward calculus and into calculus, you'll find that the natural base of our number system is this completely irrational number. 2.71 blah, 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 and it just goes on and on and on and on. But that turns out to be the natural base of our number system. Okay? Like pi is another irrational number. 3.14159 blah, 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 and it just keeps on going forever without it. So those are two very special numbers. And that's why when I looked at this, I say, why are they putting exponentials in here? Because E stands for exponential. Actually, it doesn't. We call it that. This number was developed by a very, very famous mathematician called Euler, but it's spelled E-U-L-E-R, and they named it after him, E. Euler. Okay. All right. So, yes. What's that again?
How do we get the E, the negative E? Do we do, so do we subtract the 8?
Okay. What we do is factor out or distribute out the E squared.
Right.
Because those are all the same. Okay?
Yes.
And then your coefficients are
3
plus,
5,
which is
8,
minus 9,
1.
negative 1.
Negative 1. Okay.
Right.
Right.
That's what
Okay. I thought that.
You don't have. You could write the 1 in there, but most of the time, being lazy, I don't.
That's right.
Right. Okay. All right. Good deal. Good question. All right. Let's see what they say about it. The polynomial can be simplified, and that's how they simplify it, like we did. And its degree is 2 because that's its exponent, and it's a single term, so it's a monomial. Okay.
And it's monomial because it's only all the terms are like, so it's only one.
Okay. Your answer only has one term.
I mean, one
See,
term.
this has
That's
two
right.
terms. It's separated by a plus or minus.
Right.
There's nothing on this side of the minus sign, so that's just a single term. Okay, good deal. Good questions. All right, let's go to.
Wait.
Okay, yeah. Oh, wait. Okay.
Thank you.
Okay, everybody got it? Okay. Got it? Got it? Got it? Okay. All right. Next is evaluate. And by the way, the two examples, A and B in the book, are slightly different from the one we just did. And then they have the ones in the margin, A, B, and C in the margin, slightly different from the ones we did. So let's move on to objective 3, which is evaluating polynomials. Okay? Now, find the value of, that's how you evaluate. Here's a polynomial. 3h to the fourth minus 5h to the fourth, I can't read, minus 3h squared plus 4h plus 7. When h is equal to negative 3. Now, before we deal with that part, tell me something about that polynomial. Describe it to me. This is a review of what we were just doing. A four-term polynomial, you got it right. And? Fourth degree also. It's a four-term polynomial, 1, 2, 3, 4 terms, but maximum exponent is 4. And it's in descending orders of the power. Okay? It's missing a third power, but it's okay. 4, 2, 1, 0, blast off. Okay. Now, let's find the value, or this is a way of saying evaluate that polynomial when h is equal to negative 3. So what would we do? 5 times a negative 3 to the fourth power minus a 3 times negative 3 squared plus a 4 times negative 3 plus a 7. You just plug it in, Okay? Now let's start with that first one. That's 5. Oh, and what do you do first, by the way? Exponent. Don't multiply first. Remember, please excuse my dear Aunt Sally, no parentheses here except around the negative 3's. They don't have any operation inside the parentheses. So then we do the exponents next before we multiply. So write down the 5. We're not going to do anything with that yet. And what's negative 3 to the fourth power? Anyone have a guess? Negative 3 to the fourth power. 81 on the nose, or somewhere close by. 81. Okay? Now, I don't know how you did it. Okay. 2 things. Huh? Yeah, that's what I did too. Anytime you have a positive number raised to a power, guess what? It's positive. Anytime you have a negative number raised to a power, it's negative if the power is odd, but it's always positive if the power is even. Because a negative 3 times a negative 3 is a positive 9. And then you do that again, you get another positive 9. 9 times 9 is 81. That's how I do it too, rather than multiplying each time. I split it up. Okay? So that's how we get a positive 81. Next. Negative 3, don't do anything with that yet, times 9, because negative 3 squared is 9. Any negative number raised to an even power is positive. Next. Second? Okay, you can do the plus 4 times negative 3, because that's to the first power, plus 7. Okay? 5 times 81, anyone know that off the top? 405. Okay. Minus 27, minus 12, plus 7. Now, once I get it to this form, I kind of like to combine positives together than to combine negatives. So you can do it any way you want to, as long as it's right, okay? So that would be, if you combine the positives together, that's 412, minus, combining those together, is 39. And when I do that subtraction, say again? 373. That sounds reasonable. Positive. Okay? Make sense? Now, if you like to do one at a time, if you like to use your calculator, it's fine. But just be careful with it. Goodness gracious.
Okay, Mr. Fowler, okay, 5 times 81 is 405, 9 times 3 is negative 27, 12 plus 7, 412, okay.
Okay, plus 4 times negative 3. Yep, that was from here. Times -3, because it's just to the first power.
Okay,
Yeah, got it? -12, and then 3 down plus 7.
and then the 39?
Oh. That's how I was doing it. I added the positives. 405 plus 7 is 412.
Okay.
And then minus 27 minus 12 is minus 39. And then I subtracted that. He subtracted it. Okay. You don't have to do it the way I do. If you prefer it your way, as long as it's right, you can do it. I have to me, I'd rather you see and understand the way you're doing it rather than you have to do it my way. Okay, that's not math. Math requires interacting with it. All right, for me to erase this, we're going to show how they did it. Okay? Can I erase?
Yes.
Okay. All right, let's see how they did it. They wrote it down again. That's a clever thing to do. Okay, and then they was plugged in the -3 everywhere they saw an H and left the coefficients the same and the exponents the same. Okay? That's called substituting. Okay? Then they did the math, and that was 5 times the -3 to the 4th is 81, minus 3 times the -3 squared is positive 9, plus 4 times the -3 is just -3, plus 7. Okay? Let's see how they did it here. -405 minus 27 minus 12 plus 7, exactly like we did. And they just wrote the answer down, okay? They added and subtracted is what they said. Well, of course they did. You can do it any way you want to. It almost suggests to me they were just doing it on a calculator, which is fine, as long as you can look at it and see if it's a reasonable answer, because some calculators will follow what they call rules of order of operation, okay, and some don't do it so okay. So I always like to do it in my head, at least a ballpark figure, to make sure the answer I'm writing down makes sense, even if the calculator's telling me. Okay, so that was example 3. Now, that's the A part. Can I move on? Got it? Okay. Here's 3B. Same problem, but now we're going to do it when H is equal to 2. So what will that be? 5 times 2 to the 4th minus 3 times 2 squared plus 4 times 2 plus 7. Well, again, you do exponents first. What's 2 to the 4th? 16. Excellent. 2 squared is 4. And 4 times 4 is 16. Got it. Next, minus 3 times 4 plus 4 times 2 plus 7 plus 5 times 16. 80. Is that what I heard? Okay. Minus 12 plus 8 plus 7. The way I usually do this, 8 and 7 are 15, and 80 would be 95. Minus 12 would be 83. You can do it any way you want to, punching it on the calculator, whatever. Okay? Gave you 83. Any questions? You see how we did it? You don't? Oh, no questions. Okay, got it. Okay. I thought it looked like you were following it. Okay. Notice when you have positive numbers plugging in, you don't have to worry about the signs. A positive number to any power is always positive. Negative number to odd power is negative, but negative number to even power is positive. So you have to watch out for those. Now the coefficients can be plus or minus, like we've seen, but that's fine. All right.
And we got when H equals 2 is our coefficient that we're using to multiply with, because H is equal to 2. Is that correct?
Okay. The 2 is the value of the variable we're plugging in.
Okay.
The coefficients are the
Five
numbers
and
in
three.
front. 5,
That's right,
negative
5 and
3,
3.
4, and 7.
Okay, I'm sorry. And so, okay, so 2 is the number that we're plugging in. Okay.
Yeah. Now, we do get a little sloppy maybe sometime because that is both a subtraction sign. In fact, that's exactly what it means here. But then I turned around and called it a negative 3 coefficient. You know, it's one or the other, but it works both ways. I mean, usually pans out okay. It's just that we get a little sloppy sometimes with that. Okay, let's see if there's a C part. There's not in the book, but let's see if there's one here. Oh, let me clear my screen. Okay, to clear it?
Yes.
Okay. So there they plugged in 5 times 2 to the 4th minus 3 times 2 squared plus 4 times 2 plus 7, 5 times 16 minus 3 times 4 plus 4 times 2 plus 7 is 80 minus 12 plus 8 plus 7, and that gave us 83. They don't show you how they did it, but it gives you the same. Is there a C? I take it not. Okay? In the book, there's not either, I don't think. Is there example 3? No, just A and B. All right. Now, as if we haven't already been doing it, okay, we're going to be adding 2 polynomials. And how you do that? To add 2 polynomials, add their like terms. If they don't have like terms, first bring down every term that doesn't have a common term in the other one. Okay? So really, we sort of were doing that way back at the beginning. Okay? So here's example 4, the A part. Let's add these 2 polynomials together. Now, I'm going to string it out to begin with. Okay? And then I'll let you decide what shortcuts you would like to take. Okay? And what I mean by stringing out is writing it this way. 8y cubed minus 7y squared minus y plus 3 added to 6y cubed plus 2y squared minus 4y plus 1. I have to get a monotone voice when I do it to you. Never mind. Okay. And then, because there's pluses and nothing else, you can just lose the parentheses. Now, I'm going to cheat on it when I'm losing them. I'm just going to erase them because I've got the magic pen. I can do that. Okay. Okay. So we're adding those 2. Well, guess what we do? We just combine like terms. There's y to the 3rd power. Combine those. What do you get? 14y cubed. Combine our squared powers, and what do we get? Negative 5y squared. Combine our, our linear terms. That's to the 1st power. Is what? Okay, you're faster than I am. Minus 5y. And then you combine the constant terms plus 4. Now, you don't have to do it that way, whatever way you see best. But remember, you can only combine like terms. The like terms there were the cubic terms, the squared terms, the linear terms, and the constant terms. So combine them however you want to. Adding is pretty easy. You don't have to worry about changing signs or anything else. Just add them. And again, we count this as a minus 7 and a plus 2, so that gave us minus 5. Okay. And a minus 1 and a minus 4 also gave you a minus 5. Plus 3 and a plus 1 gave you a plus 4. 8, I've left it off, but 8 plus 6 is 14. Make sense? Okay, any questions? All right, to erase? No? Okay. Okay? Everybody? Okay, wait. I know my lines are sloppy and stuff, but that's sort of how I think sloppily, you know. Notice that both of those polynomials were written in descending order of the power. And you see one reason here it's advantageous to do so, because then the powers, you see them coming up. If all those powers had been all mixed up, you probably still could have picked them out, but it would just been a little more work. And I don't like work, okay? So it just makes life easier to keep it simple. Okay? Okay? All right. Let's see how they did it. Write terms in columns. Okay, if you want to do that, you can. That's one way to do it. I hadn't thought about doing it, but you certainly could do it that way. Okay? Some things I like to do vertically. A lot of things I like to do horizontally, like sleep, but never mind. And they like to do it in columns. Fine, do it that way. And then it's pretty obvious 4 and 8 and 16 is 8 and 6 is 14 y cubed. You're distributing here. Minus 7 and 2 is minus 5y squared. Minus 1 and minus 4 is minus 5y. And plus 4. That's what they're going to do next. Want to bet? Here it comes. Now add column by column. Okay? Oh, they started over there. Clever of them. Don't know why. That came a plus 4. That became a minus 5. That became a minus 5y squared. And that became a plus 14. Just 14y cubed.
That sort of looks easier. Well, it would be for me.
What's that?
It would be easier for me.
Yeah, to put them in columns.
Plug it in there.
Yeah, I agree. It's pretty easy. I just hadn't thought of doing it since it was there. I was just lazy enough. I was going to write it down again, So, but yeah, that does make it maybe easier to see. Okay. Any questions on that? What you would also do, let's say that this was a fourth here, that was a third. Then bring the 8y fourth out here, and do 6y cubed here, and then put the others in. And then there's nothing to add, so you just bring it down, nothing to add, bring it down. So doing it this way also helps you detect any missing terms. And don't combine them if they're not the same terms. Okay. That was example 4A. Let's see. Whoa, wait. Yeah. What's that?
What page are we?
That's on page, bottom of page 852. Okay, and every one of these, there's another example in the book, and they show you how to do it, and then another example in the margin of the book. They don't show you, but they give the answers. Okay, and there was your answer for example 4A. Okay? Okay, they're going to string it out and say 14y cubed. Oh, okay, I don't know why they did it that way. Here's the B part. You want to do it columns this time? This is sort of dumb. Have y'all heard of goodness gracious, what do they call it? It's not incinerating, but that's what it means. That some people choose to I can't think of the term now, but when they die, rather than take up space, and stuff.
You mean cremated?
Cremated. I couldn't think of the word cremated. And then, so they have an urn with your ashes in them. And then you could do, and our church decided to have a facility for that if people chose to do that. And they call it a columbarium. Where that name comes from, I don't know. And a guy I know who's actually a pastor himself, he said, where's that word from? And then he said, I figured it out. You bury them in columns. Okay? No, that's really bad. But anyway, because they're stacked up there, you just open the door, put the urn in and close it up, lock it up, whatever you want to do. Okay, but let's do this one. You want to do this in columns?
Yes.
Okay, so you tell me what to write. 7n to the third. Then you skip a space because you don't have an n squared term. And then you do plus 2n. Okay, and then the next column, you don't have an n cubed. So skip that space, but you do have an n squared, so you put your n squared. You do have a linear term, so you do a minus 9n, n columns, and then you have a constant here you didn't above, that's a plus 12. All right? So don't line up things that are not like terms. Be sure that, and this is again the advantage of having it in standard form, descending orders of the power. Pick out those, the exponents and line those up together. That's why we skipped the space there, because we had an n squared here, didn't have one there, skip the space. Okay? So, what's your answer here? 7n cubed. It had nothing to add to it. Plus n squared. You didn't have anything to add to that. Minus 7n. You did have things to add there. Plus 12. You had nothing to add to that. All right? Does that make sense? Now, even when you're missing terms, you still find this easier to do?
I was just looking at that when I was.
Yeah. Yeah. Frankly, I would have looked at this and said, that's the only one here, 7n cubed. That's the only one there, so plus n squared. I'm doing it in descending order of powers. Then combine these two, because those are alike, minus 7n, and there's not there, that's the only one you have like this, so plus 12. So either way you want to do it. Whatever you see, you understand as long as it's right. Okay? I don't care how you do it as long as you get the right answer. That's what I'm interested in. All right, for me to erase. All right, let's see how they did it. Write them in columns and notice how they skipped. The n cube column here, the n squared column here, and the constant column here. Okay? Once you get them there, pretty easy to add. Let's see if they're doing it right to left again. Now add column by column. Okay, got it. Yep, they did the 12 first. Then they did the minus 7n second. Then they did simply n squared plus n squared. Now, if you don't see a sign in front of it, because the n squared leads off that second polynomial, that's all. If you don't see a sign in front, assume it's positive. Okay? And then 7n cubed. And again, it's positive, but you don't have anything in front of it, so you don't have to write the plus in front of it. And then they'll block in their answer. And then I guess they did on the last one. No, they didn't on this one. On the last one, they, for some reason, circled or put a block on the 7n cubed. But they didn't on this one. Any questions? Make sense? All right. Example 4b. That's all they have in the book too. So let's move on to example 5. Now they're adding polynomials horizontally. Okay? You can do it any way you want to. But they're doing it like I started off doing it, putting the parentheses in there. But you see, if nothing precedes a parentheses, you can lose it. If only a plus sign precedes a parentheses, you can lose it. If a minus sign preceded, keep that parentheses, distribute the minus across there. If this had been plus 7 in front, distribute the 7 across. Or minus 3, distribute the negative 3 across. But when it's only a plus or nothing in front of it, just lose the parentheses. Okay? Now, again, look for your like terms. Okay? They did the little errors like I did, except theirs are a little neater than mine. Okay, you have a 2n to the fourth minus 5n to the fourth. What does that yield? Help me. Oh, wait, we should have been doing this. Well, I'm letting them do it. Is that okay? All right. Negative 3n to the fourth. Next, you tell me. Negative 15n to the third. Let's see. There's those two. This one they circled. And that gave you a negative 15n cubed. and then the last ones are plus 6, because they didn't have any linear terms or squared terms, but they did have a constant term plus 6. There we have it. So either way you want to do it is perfectly fine. Whatever you see best, you understand best, go for it. Okay? That's 5A. Now,
Almost through.
oh, sorry. I'll leave it. At least I didn't erase anything. It all comes back if I don't erase it.
Okay.
Got it, everybody? Got it? Okay. This time, let's us do it first.
Oh, 7p to the third.
7p cubed. That's the only one you got. Write it down. Next.
Minus 4, 4p.
Minus 4p. Okay? Minus 5. That's it. The last one was this one. Okay? That first one didn't have anything to add to it, so just write it down. You're adding 0 to it. All right? Yes?
What is the test?
The test? Okay, when we do the test, it'll be in class. Remember?
Yeah, the next one then?
Oh, did you get the quiz last time?
Yeah, I got the quiz.
You got the quiz. Okay. But yeah, when we take the test, it'll be an in-class test. Anyone here didn't get the quiz last time? Okay. It's a long quiz, far longer than I would have made a quiz. This was one they had in their resource. So, anyone else need a quiz? See, y'all folks are here. Good deal. So people are not here. I don't know what's happening with them. Yes.
You have like some type of review day?
I'm sorry?
You have like a review day?
That's why I asked at the beginning. Any questions? That's when we do our review. Okay? So if you're working on the quiz and you don't see how to do one, again, if it just needs a clarification, I'll do that. But if you don't know how to do it, find one like it in the book. Every one of those has something similar to it in the book. I'll work anything in the book, as long as it's not identically the same problem. So that's how we do our review. Okay? I don't want to review everything if all of you know it already. That'd just be a waste of time. So you bring me questions. Okay? Huh?
Any homework? Any homework?
I can't hear. Homework? Oh, okay. Homework will be, you know your grade. Okay. The examples we didn't do in the text, you can do those. The grade you can do. And then
I'm sorry, pages.
The homework will be starting on page 855, 13.1. The concept check is sort of fill in the blank type stuff, 1 through 6 there. And then 7 through 16, any of those you want to do. Any that you want to do 17 through 30. And then any that you'd like to do between 31 and 40. And then do some of the ones between 41 and 48. Do some of the ones between 49 and 58. Then do some of the ones between 59 and 70. Then do some of the ones between, now we haven't done these in class yet, 71 through 76. And 77 through 82. And then either 83 or 84, if you'd like. And you can look at the 85 through 88 if you'd like. It's just sort of a review type thing. All right. Now, I'll probably go over those again at the end, but that was example 5B. Okay. Let's do, were there any questions on that? Let's go to example 6. Oh, wait. I'm sorry, I forgot. I hadn't let them do their thing. Okay. First, the cubic terms, there's only one. Write it down. Write it down. Write it down. There we go. The P terms, there's 2 of those. Combine those and you get negative 4P. Then there were no square term, no, okay. Then go to your constant terms, and you got -5. That's all, folks. I wish I could make it harder. I haven't figured out how to do so. It's just so simple, right? There's your answer. Big red square around a yellow space. Okay. Now, that was example 5, right? Yeah. Example 6, we're moving into subtracting polynomials. To subtract two polynomials, change all the signs of the second polynomial and add the result to the minuend, which is the first polynomial. Remember how they used to name that? The minuend on top, the subtrahend on the bottom, and the difference is the answer. Never use those words anywhere else except there. Okay, I've never heard of them before, except I learned them back when I was in the 2nd or 3rd grade, whatever. Okay, never use them anywhere else except that. So it's just like we do adding or subtracting sign numbers. You're just subtracting sign terms, like terms. Okay, so let's do example 6A. How would you do that? I would write down 3x, because see that parentheses, there's nothing in front of it. -5, nothing in front of it. But now I distribute the minus sign inside, and what does that give us? -6x plus 4. Now this is how I do it. The book will probably do it slightly differently. You choose however you like to do it. Now what do? Combine like terms. What like terms do you see? An x term, and that gives us -3x, and also a constant term, -1. Okay? If that was a plus sign in between, just lose all the parentheses, combine like terms. However, with a minus sign in front, you have to, on that second one, the subtrahend, you have to negate each term inside the parentheses, because you're subtracting. Okay? Are we almost out of time?
It's time.
It is time. How could that be? We were just having fun. Okay. I got another class to go to, so I better quit. Let me just show you how they did it. They wrote it down. Good for them. Change the signs in the second polynomial and add. That's what I did, except I lost the parentheses, just changed them as I distributed inside. And that gave us, all right, there we go, -3x and -1. It takes them a while to do it. All right. If you need it a little longer, we'll start next time at 6B. Okay. You didn't quite finish the chapter, sorry. I will just run over all those homework exercises. You got them, right? Now, quizzes, if you got it, I'll take it. And since it doesn't look like I have many coming in, what you could have the test on Monday or Wednesday. I was afraid of that. Okay. I'll have these graded. Oh, y'all got them. Okay. Okay, right. All right. Right. Yeah, that's it. No, and you'll need to take a test or something on the first test too. Okay, anytime you're also does. Okay. Yeah, early in the term. Okay. And if you want to get that done, that'll be fine. Uh-huh.